Hi everyone, myself Dr. A.Victoria Anand Mary, Assistant Professor, PG and Research Department of Computer Science, St. Joseph College of Arts and Science Autonomous Cuddalore. In this presentation, we can learn about Q data structure from Fundamentals of Data Structures. Subject code is CS204S. The agenda of this presentation is basic introduction of Q and operation that can be carried out on the Q. Now let's learn what is a queue. A queue is a linear data structure that follows the first in first out method to process any of the data. And for doing so, the queue has two ends, that is rear and front. The rear end is always used to insert the data, and this process is termed as NQ, and the front end is used to remove the data, that is DQ. And you can think of a queue as a waiting line. A person who arrives first gets served first, ensuring fairness and order. The first come first serve approach forms the foundation of the queue operation. As we have seen, in the queue only two operations are allowed, that is NQ and DQ. NQ means to insert an item in the back of the queue, and DQ means removing the front item from the queue. Enqueuing represents adding item to the queue like joining a line, and DQ signifies removing the frontmost item like getting served at the counter. These processes maintain the first in first out order. Example for a queue, this is the people standing in a railway reservation row. For both the operations, that is NQ and DQ, the queue data structures maintain two data pointers, that is front and rear. The pointer is actually a variable which is going to hold the address. Front pointer is going to hold the address of the frontmost element that is present in the queue, and rear pointer is going to hold the last element that is inserted in the queue. And these are some of the steps that should be taken to ensure the new item is inserted into the queue. The first step is to check whether the queue is full. And if the queue is full, it is not at all possible to insert a new element into the queue. And if we find the queue is full, we are going to produce the overflow error and exit. Otherwise, we are going to increment the rear pointer to point to the next empty space and add data element to the queue location where the rear is pointing currently and return success. When we reach this point, that is success point, we can ensure that we have inserted a new element into a queue. Here we can see that the new item D is enqueued in the queue. For doing so, the rear pointer is incremented to point to the next empty space, and the element is inserted in the location where the rear is pointing. This is our algorithm for NQ operation. As we know, the NQ is inserting a new element into the queue, and the procedure name is NQ, and we are going to insert the data. For doing that, we are going to check whether the queue is full. If it is full, we are going to return overflow and end this particular if statement. Otherwise, we are going to increment the rear by 1, that is rear equal to rear plus 1, and we are going to store the data where the rear is pointing in the queue and return true. And this procedure ends here. And as we know that the enqueue operation is used to add element to the queue, when we enqueue an element, it gets added to the rear, that is rear end of the queue, and when we need to make sure that the queue is not already full before enqueuing a new item. This is the overview of this enqueue operation. DQ means to remove any data from the queue. The step to remove any data from the queue is given below, and for doing so we have to check whether the queue is empty. If the queue is empty, we are going to produce an error, that is underflow error, and exit. If the queue is not empty, we are going to access the data where front is pointing currently, and we are going to store that data so that it can be used for future reference, and we are going to increment the front pointer to point to the next available data element and return success. This is the diagram representation of the DQ operation. That is, if we are going to delete any of the item from the queue, it will be done only in the front end. It will be done where the front pointer is pointing. Currently, the front is pointing to the data element, that is A, and the A data element will be deleted from the queue. Now let's look at the DQ operation. This operation removes an element from the front end of the queue. Similar to the NQ operation, we need to check if a queue is empty before dequeuing any of the element from the queue. The algorithm for DQ operation, that is, the procedure name is DQ, and we are going to check whether the queue is empty, and if it is empty, we are going to return underflow, and the if condition ends here. And if it is not empty, we are going to store the data element that the front is pointing to the variable data, and we are going to increment the front by 1, that is given as front equal to front plus 1, and return true. That is it, true in the sense we have deleted the element that the front is pointing, and the procedure ends here. And in the conclusion, we can understand that queue offer a simple yet powerful concept for organizing and processing element in a first come first serve manner. Thank you all.